All right, welcome. This video is going to be for a class on Tuesday, April 6th. And what you should do today is you should be looking at page 24, which says some mole map notes and practice. And if you take a look at this page, we start out here with a review at the top of what we have done so far. So on pages 20 and 21, we did some one-step stoichiometry problems using mole ratios. And if you are looking at your copy of page 24, you can click on this link right here to take you to that lesson reviewing the concept. We talked about chemical reactions being kind of like recipes that tell us these ratios of amounts of reactants we need to make a certain amount of product. And then we can use these ratios to do some calculations. So for example, if we want to make 10 moles of lead, let's see, or if we want to react 10 moles of lead nitrate, we could figure out how many moles of lead chloride could be made. Or if we wanted to make 5 moles of aluminum nitrate, we could figure out how many moles of lead chloride would also be created. So this is kind of the real, practical reactions that we do in the lab. If you want to produce a certain amount of product, you have to figure out how much reactant you need to mix together to get that product. So that's what we're looking at here with stoichiometry. So we start out with one-step problems. We're just going from moles of one thing to moles of another thing. And then we did some two-step problems. We did those on pages 22 and 23. And with these two-step problems, for example, maybe we had a certain mass of reactant and we want to figure out how many moles of water could be made. So we're adding an extra step here. So first, we have to convert grams into moles, and then we're going to use our mole ratio to find the moles of product. And then there's a video link right here you can watch to review this type of problem solving. And notice when I'm showing my work here, I tend to represent these ratios as fractions. Like I show a number multiplied by a fraction. That's the way I like to show it. There are other ways in which you can represent your work. A common way that people also like is setting up these two fractions equal to each other and then cross multiplying. So for example, if we go back up to this type of problem, you could say that, if you have 5 moles of aluminum nitrate, you're trying to figure out how many lead chloride, that's your unknown. And we know from this chemical formula up there that we know that for every 2 moles of aluminum nitrate, we make 3 moles of lead chloride. So then you can cross multiply to solve. So that's just another approach. So there are different approaches you could take. Just make sure you're showing your work and you're labeling these numbers with units when you're showing your work there. All right, so we've looked at one-step and two-step calculations. So you might guess what we're going to do today is we're going to look at three-step calculations. So if you will scroll down here, we've got a visual of what we call the mole map. And the mole map is something that's commonly used to help us problem solve and figure out what the first, second, and third step should be in our calculation. So it's a little visual here that you might find handy. And we are going to take a look at an example of how to do a three-step calculation and how we might use the mole map to help us out here. So we're going to take a look at a sample problem here. Let's say we have this reaction. We're looking at nitrogen and hydrogen gas coming together to form ammonia. And the question is, how much ammonia could you make from 75 grams of nitrogen? So let's assume we have a lot of hydrogen hanging out, but we've got 75 grams of nitrogen. How much product could we make in this reaction? So if I'm thinking of this in terms of my mole map, what I'm going to do is I'm going to look at my mole map and I'm going to say, where am I starting? Okay, I'm starting over here with grams of a reactant. And then, so that's my known. So whenever you're problem solving, it's always good to ask yourself, what do I know? And then what am I trying to find? So what I'm trying to find is grams of NH3. So that's my unknown. That's what I'm trying to find, however you want to label it. So I want to find grams of this other thing. And so if I take a look at this, I want to get from over here to over here. So that's like it's going to take me 1, 2, 3 steps. So that's what this mole map helps me do. It helps me figure out how many steps I need to take and what those steps are going to be. So it looks like from the first step on my mole map, is the first thing I want to do is want to convert grams to moles. Okay. And if you see on this page, there's a problem that's worked out for you. So you can see step 1, convert grams to moles. And here are a couple of examples of how you might show your work for that. So when you're converting grams to moles, you're going to use the molar mass. Okay, and the molar mass is something that you find on the periodic table. And this is something that we first saw in Unit 4 when we looked at mass and moles. So if you look over here, I pasted a periodic table over here. That's always a handy thing to do. And nitrogen, down here, the molar mass of a nitrogen atom is 14 grams per mole. So an N2 molecule has 2 nitrogen atoms, so we're going to add up those masses. So the molar mass of the nitrogen molecule is 28 grams per mole. So I'm going to choose a strategy, however you want to show your work, to figure out how many moles of nitrogen I have. Okay, so that's step 1. All right, check. Step 2 is I'm going to go from moles of nitrogen to moles of ammonia. How do I do that? Well, I'm going to use my coefficients in the chemical equation. That tells me my mole ratio. Remember, those coefficients basically tell me the recipe, like how many nitrogens I need to make a certain amount of NH3s of ammonia. Okay, so now let's scroll down and look at this example. So we did step 1. Let's scroll and look at step 2. Here we go with step 2. So we're going to convert moles of N2 to moles of NH3. The way we do that is we look at the coefficients. We see it's a 1:2 ratio. So we make 2 moles of NH3 for every 1 mole of N2 that reacts. So I can set it up this way over here. This strategy is called dimensional analysis. We introduced it in Unit 4. If you don't like this strategy, there's other things you could do, like you could set up fractions. You could say for every 1 mole of this, we make 2 moles of this. So if we react 2.68 moles of this, how many moles of this would we make? So that's another strategy. So that's step 2. Okay. Now let's go back to the mole map and see where are we. Okay, step 2, check. So now we're going to do the last step. Step 3 is I want to go from moles of the thing I just calculated, which was NH3, and find grams of NH3. So again, I'm going to scroll down, and this is in your notes already as an example, so you can refer back to it. So here we go right here. Here's our last step. We want to convert from grams to moles. Again, there's different strategies we can use, but the main information we're going to use whenever we're going from grams to moles or moles to grams is we're going to look at the periodic table and look at the molar mass. I just realized in here I had the irrelevant molar mass written down. That's not relevant to the problem. Okay, so when I want to go from moles of NH3 to grams of NH3, I want to know the molar mass of NH3. So what I'm going to do is I'm going to look on the periodic table, and I'll notice that, here, I'll scroll over and show you again real quick. Where is it? That nitrogen has a mass of 14, hydrogen has a mass of 1. So I'm going to add up 14 plus 1 plus 1 plus 1. That is, so that's the mass of nitrogen plus hydrogen plus hydrogen plus hydrogen. So that is 17. So what that means is, what that number on the periodic table tells you is how many grams 1 mole of that substance weighs. So 1 mole of NH3 weighs 17 grams. All right. So then I can do a calculation here where I take my 5.36 moles of NH3 and convert it to grams. And then I've solved my problem. Boom. So if I go back here to my mole map here, I just did step 3. I converted from moles to grams. Okay. So here are my 3 possible steps. This is the longest stoichiometry problem that we will see. And you can see that within this mole map, you can also see the other types of problems that we did. So we started out just going from moles to moles, and then we did some grams to moles, and now we're doing grams to moles to moles to grams. So now we're doing this 3-step process. And the information you're going to use, you're either going to use the molar mass from the periodic table, or you're going to use the coefficients from the chemical equation. Those are the 2 kind of outside sources of information that you're going to use in this type of problem solving. So we're going to go through and do a couple other problems. So follow along on your page 24, whatever page this is. So if you can follow along on this page, yeah, and fill these in so I can see that you're watching this and processing. And if you have questions, send me a chat message. I'll just be seeing if you're following along with this in your OneNote. Again, if you're feeling stuck, please send me a chat message. All right, so here's a problem. We're trying to find grams of ammonia. So that's our unknown, is grams of ammonia. So I'm gonna put a little question mark by it. And our known is we have 10 grams of nitrogen. This is our known. So if we look at our steps here, we are going to, actually, if you scroll off here to the side, I've got another little version of the mole map right here. So we're starting with grams of nitrogen, and we want to find grams of ammonia. So step one is we're going to convert grams nitrogen to moles nitrogen. I'm going to use the molar mass on the periodic table. Then we're going to take moles nitrogen, convert it to moles NH3 using the coefficients from the chemical equation. Then once we know moles NH3, we can find grams NH3, again, using the molar mass on the periodic table. All right, so those are our steps here. So step one is we're going to take our known, the 10 grams of nitrogen, and we are going to convert grams nitrogen into moles nitrogen. So 1 mole nitrogen is 28 grams. And again, we find that by looking at the periodic table. And I'm going to stop and write this down, 0.357 moles N2. I'm not particular in how you round it here. I would say, you know, generally keeping 2 past the decimal is fine there. So if you round to 0.36, that's good too. Okay, so that's step one, is we went from grams to moles. Check. Next step is we're going to go from moles to moles. So if we have 0.357 moles N2, we want to convert that into moles NH3. So I'm going to convert moles of N2 into moles of NH3. So never mind, it's 1 mole of N2. I find it from looking at the coefficients here. There's nothing written. I assume that's a 1. And it looks like it's a 1:2 ratio. So for every 1 N2 that reacts, I make 2 moles of NH3. So I'm going to take my previous answer and multiply it by 2. So I end up with 0.714 moles of NH3. And then my last step, I want to find grams of NH3. So I'm going to take my moles of NH3, and then we're going to look at the periodic table, and we add up the molar masses. Remember we did that up here, and we saw that 1 mole of NH3 weighs 17 grams. So I'm going to take my answer here and multiply it by 17, and I get 12 grams of NH3. That's my final answer. Or maybe you got 12.14. Whatever you wrote down with the decimal is fine. So that's an example of a 3-step stoichiometry problem. Again, there's different ways in which you can show your work. So like, for example, on this step, if you wanted to, you could say that you could set up 2 fractions and do some cross multiplying. So you could say, well, you have 0.357 moles of N2, and we know the ratio is there's 1 mole of N2 per every 2 moles of NH3. And then you can cross multiply, and you will get the same answer. You'll get 0.714. So it's just different ways of showing your work, whatever kind of works for you. But again, what you do need to do is to show your work. If you just write down a numerical answer here, then you will not earn credit because I do not know what you were thinking, and so show your work here. Okay. Let's look at one more of these. Okay. So in this case, we're trying, our unknown is grams of nitrogen gas, and our known is grams of NH3. So we're going to go from grams of NH3 to grams of N2. And let's actually map out what these steps are. So we're going to go from gram to gram. First step is we're going to convert grams NH3 to moles NH3. And then we're going to convert moles NH3 to moles N2. And then we're going to convert moles N2 to grams N2. So that is our 3-step process right here. And again, you might find this helpful as kind of a generic setup, trying to figure out what your steps are going to be. This might help you. Feel free to like snip this and paste it next to your practice problems here. Okay. So let's take a look at this one. So we're starting with, 50 grams of NH3, and we know that 1 mole of NH3 weighs 17 grams. How do we know that? we looked on the periodic table. We added up the masses of nitrogen and 3 hydrogens. All right, so I'm going to divide this as 2.94 moles of NH3. So next step, so step 1 is done. Next step, I'm going to go moles NH3 to moles N2. Notice if you like doing this fraction method that I use, it's something called dimensional analysis. And you might notice a pattern here that whatever unit I have here goes on the bottom. So like if it's moles NH3 on the top, it's going to be moles NH3 on the bottom of this fraction here. So notice how here grams was right here and grams went on the bottom of the fraction. That's another way you can help figure out how to set up these ratios here. So I'm trying to find N2. And if you look, I gotta look back at our, here we go. Looks like it is 1 nitrogen per every 2 ammonias. So I'm gonna multiply that by 1/2. So I get 1.47 moles of N2. And then the last step is to convert those moles of N2 into grams. And so I'm going to do that. I'm going to look on the periodic table. And I'm going to say, okay, this looks like this is 28 grams. So your final answer should be 41 grams of N2 there. So those are 2 examples of 3-step stoichiometry problems. And again, notice there's kind of 2 sources of information we're going to use. We're going to use the coefficients from the chemical equation. Those tell us the ratios of reactants to products here. And then the other information we'll use is the molar mass, which we can find on the periodic table. All right, so these are some notes, and then there's going to be some practice problems on the next page that you can practice. And again, and there's more videos. Remember at the top of the page, there were some video links you can watch, and make sure you send me a message. You can send me via Teams chat if you have a question. All right, thanks for watching.